How's it going, everybody? And welcome back to the Cisco Enterprise Series for CCNA, CCNP, and CCIE candidates. In this video, we're going to keep on what we've been doing. We're going to go ahead and do an entry-level topic, which is going to be understanding network architectures, so topologies, and the different topologies that come into play. And I want to bring over one note real quick. Actually, I'll bring over the blueprint because the blueprint covers it too. If we look up here, we're going to be taking a look at 2-tier, 3-tier, spine, leaf, WAN, small office, home office, and then on-premise and cloud. So without any further ado, let's go ahead and dive into the minutia. So the first thing that I want to talk about is going to be the traditional networks that y'all are going to be seeing. Let me go ahead and get out of the way. And we're going to start off with the enterprise network architecture, the topologies you're going to see, which are going to be both the 2-tier and the 3-tier architectures. Now, they look the same minus a few little variations, and I'll explain why one might be used over the other. Now, in a 2-tier architecture, you're going to have a distribution layer. I'll put distribution, and then we're going to have access. So you might have distribution, we'll say dist 1, and we'll say type in dist 2. Then we'll have access 1 and 2. These guys will be connected to each other, and then we'll have cables coming down from the distribution down to access. Access won't be connected to each other. Anything that's attached to this access switch that needs to connect over here to this other access switch will have to be forwarded through the distribution block in order to get connectivity stood up. This is the 2-tier architecture. The 3-tier architecture is going to be a core. We'll say core, and I'm always going to do redundancy whenever I can. Then we're going to have dist, and then we're going to have access. Access 1, access 2, and say access 3. Now, the key differentiator here is distribution, pretty much at any level, no matter how you carve it up. Let me go ahead and just draw that out. It kind of looks like a spine leaf environment, but we'll cover that in a little bit here. We're going to have connectivity up to the core like this, and sometimes the cores will have connectivity to each other. But the key differentiator here that I want you to be aware of is this piece right here is going to be all layer 2. Anything northbound of the distribution block will be layer 3 routed. And that goes for the 3-tier architecture. You're going to have all of this here will be layer 2, and all of this here will be layer 3. It'll be routed. So what does that mean in terms of placing your logical infrastructure? Well, down here, you're going to have VLANs, you're going to have trunks, stuff like that. The distribution switches in the 2-tier architecture, this is also where your gateways for all of your VLANs are going to sit. That means that these switches here, distribution block switches, are going to have what they call SVIs, switch virtual interfaces, also known as the interface VLAN. Now, one thing that's commonly referred to as the 2-tier model is also referred to as the collapsed core. Now, the collapsed core means you are collapsing the core functionality down into the distribution block. So the reason why you need to know both is because both are widely deployed. Now, is there one way, or is one methodology better than the other? Yes, I believe there is. And let me talk a little bit about that here real quick. When we talk about architecture in terms of how it's deployed, we really need to understand it really applies to the size of the environment or the size of the location you're putting into play. Not every location is going to need a core distribution and access. Some locations will require it depending on its size, the complexity. A lot of other locations, distribution and access are going to be all you need. You might only see a core and distribution in HQ or very large data centers, or a cloud or a co-location facility might have a core. But the core, at the end of the day, really is meant to do one thing and one thing only: connect all of your other network blocks together. And let me go ahead and I'm actually going to clear the screen off because we're pretty much done explaining this, but let me scroll up here just a little bit. So if I scroll over here just a little, come over here to the left side. I'll clear the screen because I can always redraw that in a second. The thing that I want you to pay attention here on this topology right here that I've built out is that anything that's in a rounded corner rectangle or square would be considered a distribution block or a switch block or a network block, whatever you want to call it. Now the idea behind this is this stuff here in the middle, these devices right here, we've got iOS, iOS XE, iOS XR, and then Nexus. We're going to see all three variations, or I should say all four variations if you want to get super technical about it. This is going to be the core. The core is going to be used to interconnect all of the other network blocks, all the different modules that you have built in your network. Whether that is a user block, whether that is a server block, whether that is a data center block, or whether that's the internet, or if that's the WAN, or any other thing you want to throw in there. You could have a DMZ if you wanted to. It really is completely dependent on you. Why don't I have a DMZ? Simple. This is not a security series. This is a routing and switching series, focusing on routing and switching. So, could you have a DMZ? 100%. But this is more of a, if I was trying to intermix security and enterprise, then I would have a DMZ. But I don't. So, one way or the other, this is what I want you guys to be able to, when you hear the term three-tier model and somebody is mentioning it to you, this is what I want you guys to visualize in your brain is this. You have a bunch of different blocks of equipment that need to be able to talk to one another, and the easiest way to do that is to connect them to a core. Now, not all three-tier models will look like this, but a lot of them will. They might have some slight variations in how they come together, but the overarching logical structure of it is going to be this. You're going to have a core, distribution, and an access. Now, I'm going to go ahead and clear the screen again. Let me go over to the right. If you notice over here, in this site here, we have a distribution block, we have a distribution block here, and we have an access block here. Now, would you consider these guys to be the core? No, I would not. This is going to be a collapsed core. Meaning, the distribution block is where the default gateways for all the VLANs are going to sit. There's trunks going downstream to the access layer, but everything this side of it is all routed. These routers here are just edge devices connecting it to either internet or private WAN or any combination of both. So that is where that would come into play. So when you hear the term collapsed core, two-tier model, whatever the case, whatever the term is thrown at you, that is how you use that as a differentiator. Now you might be asking, well, what about this one here? Is this a distribution and access? It is. But I am going along, once we get into the actual configuration details and start doing that, I actually jumped ahead a little bit. And then I realized, I paused that and I circled back to all the network fundamentals because I was trying to get the network fundamentals portion of the series done and out of the way first. Put that out on, get that uploaded and out to you guys, and then focus on the implementation pieces. But yes, this would be a distribution, this would be access. It's a single link, and this was a smaller site, easier to work with. It still has the components that I want you guys to be familiar with, But the key factor here is that it's small and easy to digest for someone that's coming in at the ground level of networking. They're working towards their CCNA, something like that. So I didn't want to bring out of the gate and have this monstrosity over here or something more complicated like this and confuse some people. I remember being very brand new to networking and looking at a topology like that and going, wow, it's cool looking, but I have no clue what's going on. So take that for what it's worth. So that's really where that comes into play. Now, I spent the last few minutes talking about collapsed cores and three-tier model and stuff like that. So let's go ahead and shift over to a spine leaf. And the spine leaf is actually pretty straightforward. I have a couple of examples of that, so I'm going to whiteboard around the topologies I have because for the most part they get the job done. But I am going to get out of the way. So the spine leaf is actually a combination of multiple things. So let me go ahead and get that out of the way. There we go. So when you hear the term spine leaf, what I want you to think about is something like this, where you have spine 1 and spine 2, and you have leaf 1, leaf 2, leaf 3, etc. And then the leaves connect to the spines, like so. Now, the leaf switch is going to be where you connect devices to the fabric in order for them to access the fabric. Nothing should ever connect to your spines. Nothing. The spines are just there as a connection to other leaf switches. Now, in most spine leaf environments, between the spine and the leaf, this is going to be a routed fabric, meaning that there is some sort of dynamic routing set up between your spines and leaves. To keep things simple in this size of a topology and lab, I only have one spine. I have spine 1, which is Nexus 54. What I'm going to do is Nexus 56 and Nexus 55. This is going to be access 1. This will be access, or actually I should say this. This will be leaf 1. This will be leaf 2. They might say, what's up with N52 and N53? Well, that's a great question. These are still going to be leaves, right? However, we'll say this will be leaf 3 and this will be leaf 4. But the difference between these leaves and these leaves up here is these leaves connect to servers, so they are technically an access leaf. And then these leaves right here connect to the outside world. These are going to be referred to as border leaves. Now, when we do that, there's going to be external connectivity that goes out to the outside world and all that good stuff that goes along with it. It's a pretty straightforward operation, but that's essentially what it is that you need to know in terms of connectivity for a spine leaf environment. But there's more. There is one more leaf type that you could throw in here. So for the sake of argument, I'm going to draw another one over here. I'm going to hang another 9K out here. Now this leaf right here will connect down to a firewall and also a load balancer. So this might be a Palo Alto. This might be an F5. When you get these type of leaves, they don't connect to the outside world per se. They might through the firewall or bring traffic in through the load balancer, but they don't connect down to endpoints either, or servers that are responding to user requests. They provide a service. So they are a service leaf. And that's one thing that I want you guys to keep in the back of your mind, is how that comes into play. I don't have any service leaves here because I'm not trying to teach you guys how VXLAN works. I do have that there just so you guys have a visual representation of what spine leaf looks like. Everything's going to go through the spine, and yes, I realize that there's no redundancy in that environment, but you normally would have a minimum of 2 spines. Each spine would connect to each leaf, and connectivity would be put in play. Now, the key differentiator between this type of a topology and, say, everything over here is there's no tunneling involved. When we talk over here about this data center, we're going to be using VXLAN. So this will be coming further on down the road, but for those of you that are getting into SD access and things like that, you're going to need to know how that works anyway to understand how the SD access capability comes into play inside of an SDA fabric. So we'll be using VXLAN to do the job, but VXLAN is a tunneling technology. So VXLAN is analogous to OTV, Overlay Transport Virtualization, which is also equal to L2TP v3. These are all layer 2 tunneling technologies, meaning I want to ingest traffic on this switch, but then send traffic over to this switch here. But by doing that, I build a tunnel from this switch to this switch, and then inside this tunnel, I encapsulate my traffic. So what I'm actually able to do is I'm able to extend layer 2 traffic, so MAC address learning and things like that, over to another switch that also has MAC learning and layer 2 capabilities enabled on it, over a layer 3 backbone or a layer 3 fabric. So all this stuff here in the middle, this is all routed, right? We run OSPF, and then the VXLAN tunnel is an overlay. It rides over the top of that, leveraging BGP. So that's essentially what you got. We'll dive into that more in detail later. But unlike like an IP tunnel, IP is equal to layer 3 VPN, which is equal to GRE, sort of. So GRE tunnels are very similar to the way VXLAN works in terms of it's an overlay tunnel, which means it bypasses all the underlying infrastructure, and you build a tunnel between two different devices, and everything in the middle just kind of disappears. Because that's what VXLAN does. VXLAN, OTV, L2TP v3, so on and so on. IP tunnels, GRE, they are going to make all the stuff in between you and me look irrelevant. So the easiest way I like to analogize this is this. When you get in your car, let's say you're going on a road trip, and I live in the upper Midwest. Let's say, for example, I want to go to Florida. I want to go to Orlando. I want to go see Mickey Mouse, right? Well, I'm going to drive there because I have all kinds of time on my hands, and I'm in, I want to go, I like road trips, right? So I'll get in my car, I'll pack what I need, and I'll get on the road, and I'll start driving south towards Florida. Well, I'll drive through all these different states, and what that basically equates to is if I'm here, and I want to talk to this server here for whatever reason, I have to pass through all this network infrastructure in order to get to that server. Actually, let me use a different color so that it's easier for you guys to see. Let me use yellow-green. So I'm here, and I want to take this path here. Well, let me do it this way. I want to take this path here to the server, right? That green line is me going through every state from Wisconsin all the way down to Florida. So that is using the infrastructure as you see it, and you get to see everything. You get to see all the roads. You get to see all all the stuff that goes along with that. The geography of the land you're going to be traveling through. Okay, normally pretty easy to understand. Now I'm going to flip over to blue. I'm going to use sky blue, and where, let's say for example, I don't have all the time in the world, and let's say I've got a week, right? So to maximize my time, I am going to leave Friday night. I'm going to go to the airport, get on a plane. I'm going to fly from Wisconsin to Florida, and it's going to take me about 2.5 hours, right? That's about how long it does. So you drive to an airport, you go through all the fun stuff that airports provide you, you get onto a plane, and then 2 hours later you will arrive at your destination. Now what does a plane do or give you that a car can't, right? Most people don't know how to fly, right? So think of it like this. I am going to build a tunnel between these two devices, and this tunnel is going to do this. I'm going to go in this tunnel, which is the airplane, and I'm going to fly to another location. Can you look out the window and see the geography on the ground? If it's light out, yeah, sure. If it's dark out, you'll see. If you're low enough, you'll see the lights of the cities you're flying over. if you're flying high enough and you're probably above the clouds, you're not going to see anything but the stars, right? So if I come into a land, I see the area that I'm landing in, all the good stuff that goes along with that. So what a tunnel's job is to do is to hide everything in between point A and point B. So the airport, I take off from Milwaukee's airport and I land at Orlando's airport. And from there, when I get to Orlando's airport, I go get my rental car and I drive to wherever I'm going to go. Right? I'm free to go wherever I want inside of the city of Orlando or the state of Florida, however you want to look at it. So that's essentially the key difference between tunneling and not tunneling. If I'm tunneling, it means I'm hiding everything between point A and point B. The endpoints don't see it. If I do a trace route to the internet, and let's say I'm tunneling from, I have several hops in between point A and point B. If I hit the switch here, and then all of a sudden I'm on this PC down here, and he wants to pull up the web page on server 85. Well, he does that if he's tunneling. A lot of the stuff in the middle, everything between here and here, it's going to be hidden, right? There's nothing going on that's going to give me any reason to worry about it. Like, yes, I'm flying over it. Can I see it? Yes, but the logical piece of it, you're inside a plane and you're flying over it, right? That's a tunnel. So keep that in mind when you're talking about, and that's where encapsulation comes into play. So how is the tunnel built? Well, it leverages encapsulation, whether that is going to be VXLAN encapsulation, OTV encapsulation, L2TPP3, a GRE or an IP header. There's going to be something in front of your payload that's going to get you from point A to point B. Wherein you have a plane, you're encapsulated inside of a plane, right? You're inside the plane, and you're flying to a particular distance, or you're in a helicopter if you guys are, fancy or something like that. But you get my point. That is essentially what that comes into play. If that's not clear, that's fine. I know this is more of an entry-level video covering spinal leaf, but I wanted to cover that just so you guys would understand how the piece comes in. I'm going to go ahead and delete this, clear the screen off, and we're going to move into our next thing, which is going to be the WAN. So the WAN is kind of cool, right? I'm a big, that's what I spent the majority of my career doing and building is WANs. WANs are cool. Very well versed in WANs. So let me go ahead and get out of the way. Let's talk about how WANs work. Let's go back over to, I'm going to just go with yellow-green. That's kind of a cool color. The WANs, we're going to talk a couple different variations. The WAN is the wide area network. And the wide area network, key term here is wide, meaning outside of my local network. Something that's used to connect my local networks together. So if I want to talk, say, PC68 to something attached to switch 17, how do I get there? Well, everything in between here and here, right? Everything inside this big rectangle would be considered LAN, right? Now, switch 17, this would be the LAN over here. But how do I connect the two together? Because I can't go from PC68 and then connect to something behind switch 17 and plug in the IP address and then, or the DNS entry, and just expect it to, get there, right? That's not going to work that way. So what we will leverage is the WAN. So the WAN is multi-purpose, and it comes in all different shapes and sizes. So you have a metro WAN, you have the regional WAN, you have the national WAN, and then you have the global WAN. Now, what's a metro WAN? Well, let's say, again, I live in Milwaukee. So if I'm here in Milwaukee, and there's multiple little cities inside of Milwaukee. But for kicks and giggles, if I'm in Brookfield, so BF, and then I have another site in, say, Menominee Falls, MF. So if I want to connect Brookfield to Menominee Falls, I would use a Metro WAN. So you might even use Metro E, another topic altogether. But I would use the metropolitan WAN because Milwaukee is a metropolitan area. There's multiple cities that make up Milwaukee. So I would use the Metro WAN to connect Brookfield to Menominee Falls. Those are a couple of towns in the not too far from where I live. So now the regional WAN is if I want to connect Milwaukee to, say, Chicago. So I'll put down here Chicago. I refer to Chicago as Chi-Town because it's a long ways away. So if I want to connect Milwaukee to Chicago, I'm going to need a regional WAN, which is going to cover a couple different states, or it might be part of a much larger backbone, but it's part of a, it's in the same region. Anytime you're in the same region, the same thing would be if I was in, say, Orlando and wanted to connect to Atlanta, the ATL, right? If I wanted to connect these two together, I would use a regional WAN to do that because Florida and Georgia are pretty close together, right? Same thing if I was trying to connect to Huntsville from, say, Nashville. Huntsville, Alabama to Nashville, Tennessee. It's not terribly far from each other. Therefore, a regional WAN might do the job, right? Same thing with like Las Vegas to LA, something like that. So that's where that would come into play. Now, nationally, if I'm here in Milwaukee and I need to connect down to Orlando, I'm going to just put an ORL here for short. If I need to connect those two together, I'm going to use a national WAN, meaning that I have to go outside of my region, and the upper Midwest is not the same as the Southeast, so I would have to use a national-based WAN in order to get there. Now, global would be obviously something like US to, say, the EMEA region, Europe, Middle East, and Asia. Or APAC, the Asia Pacific region, or something along those lines. Or South America. If I'm going outside of my continental country, I need to connect to something and say of Bulgaria or Bolivia or Kazakhstan or China, wherever you're going, right? It really, where you're going is kind of irrelevant. As long as there is a fiber circuit ran between point A and point B, that's where a global WAN is going to connect you to. Now, the cool thing about it is most of them all look real similar to this, right? You have an edge, provider edge. Oh, and here you have a provider core, or provider, and you've got a core here, and you have more PEs, so on and so forth. And that's essentially how you could correlate that, is depending on the WAN you're talking about, this green circle would, this setup right here could be scaled for metro, regional, national, and if you were so inclined, global. It's pretty cool stuff when you really think about it, but that's essentially what you want to keep in the back of your mind when you start talking about how the WAN is going to connect. So how do you get PC68 to talk to something behind switch 17? Well, there's multiple ways that you can do that. How the WAN is set up could vary wildly. So let's say, for example, you're going to use a dedicated provider. Let's say you're going to use AT&T. And AT&T is going to give you a layer 3 VPN in order for you to connect to it. So what's going to end up happening is from R64, there's going to be a connection back to R58, and you're going to use BGP to connect to the provider edge, and then switch 17 is going to do the exact same thing, or R37 is going to do the same thing. R37 is going to connect to this provider edge using BGP, and then these routes here will get advertised this way. These routes here will get advertised this way. Let me go ahead and draw that up here. Will get advertised this way. So we'll say 10.1, that was a horrible zero, 10.1. Let's say 0.0/20 gets learned on this side. And let's say for 172.16.0.0/24. Let's say this is something that belongs right here. Well, if you're learning them back and forth, And PC68 all of a sudden now has a way to reach 172.16 by way of, let's change this over to be sky blue. Now we can take this path like that, and then vice versa. We can reverse the route this way. And that is exactly how the WAN would work. And that would be the same concept if I was to have connections going out to here, or connections going out to here, or to my data center, so on and so forth. But the bottom line here is you have a mechanism in place in order to make that happen. And that is what the WAN's job is to do. It doesn't matter if this guy here is sitting inside of Milwaukee and this site over here is sitting inside of, let's say, Paris. It doesn't matter, because regardless of the size of the WAN, it's still a WAN getting you to that. Now, it doesn't even have to be MPLS. It doesn't have to be MPLS. It could be, but it doesn't have to be. You might even set up a site-to-site VPN between this guy here and this guy here. You might VPN, and everything inside of this connection right here would be encrypted. And you could use a site-to-site VPN to get that same job done as well. Is there one way better than the other? It could go 70 different ways. It just, how do you get the connection in place? And for the sake of brevity, I'm keeping it simple in this respect. Okay, that's basically how the WAN comes into play. Pretty straightforward stuff. The next one we have is going to be the small office, home office. So I'm going to pick on this site again, Thor 37 and switch 17, because, well, they're small, right? Now, this site right here could be anywhere you want it to be. This could be your home, right? There are some companies that are cool with sending enterprise-grade hardware home with you for somebody that might work from home or whatever the case might be. Or you might have a small office inside of a strip mall or some office space in a business park or something along those lines, where you have to travel that's relatively close by to your house. You drive to this particular location, and you end up, you get a small cube that you sit in while you're doing your work, something along those lines. So when we talk about that type of stuff, small office, home office are referred to as SOHO, and not Southamptons, maybe? I don't honestly know what SOHO actually stands for. And not SOCO, not Southern Comfort. So we talk about SOHO. The environments are built very, very similarly. And that's a key thing that I want you guys to keep in the back of your mind is, operationally, these are the things to keep in mind. It's a small office. The infrastructure that's going to be there is going to be very minimal. You might only have a router or a firewall and an access point, a printer, a couple PCs. The size of the environment, the amount of hardware that's actually at the site, is 100% irrelevant to those that are network people. You might only need a /24 subnet, and over here we talked a little bit about that in a video I've already recorded. But at the end of the day, that's essentially where that would come into play. So in my home network, I have 3 /24s, one for voice, one for data, and one for management. So do I need all that? I really don't, but because I have the ability to do so, I do it. Simple as that. That is a small office, home office. If you want to know more about that, we will definitely dive into those, into design, all that type of stuff that goes along with that. All right, the last one we have is going to be on-premise cloud on-premises or cloud, both on-prem and in the cloud. So what do I mean by that? Let me take a moment here and pop back in. So when I talk about how the cloud is going to work, there's a couple different ways that you can look at that. You can look at it as from a private perspective, which means you've gone out and you've bought all the servers, you've bought all the software for, like, whether it's VMware, Microsoft Hyper-V, whatever it is you're going to be doing, and you deploy servers inside your data center or inside of a room that's got servers in it. It could be a data center, could be a server room, whatever you want to call it. You deploy all this hardware, you install VMware, because that's what I know. You deploy VMware, you've got a bunch of virtual machines going, all that good stuff. If that hardware is sitting on sitting at a location that your company manages, that location and the hardware inside of it, that's considered to be a private cloud. Nobody gets to use that but you. Now, some companies are moving towards a public cloud, whether that's AWS, Amazon, AWS, Azure, IBM, Google Cloud, whatever name brand you want to use in order to get your cloud on. That's up to you and how you want to do that. So AWS and Azure to me are the more ubiquitously deployed ones, but Microsoft, VMware has their cloud too, but not as widely used as far as I know. So you can do a lot of VMware on AWS. So like we're VMC, VMware on cloud, VMware on AWS, so on and so forth. So when we talk about going out and getting a connection to AWS and all that other good stuff that goes along with that, you buy the resources that come in the cloud. And the cool thing about that is you're changing your CapEx OpEx model, meaning if you stay private cloud where everything's on-prem, your CapEx is going to be high initially because you got to buy all the stuff that you want to use. Then you're also going to have an operational expense to that where you're going to have to keep the stuff running. Where a public cloud, your capital expenditure is probably going to be not as bad up front, but your operational expense is going to be high because you need to be able to pay for the services that you're leveraging, right? That's the whole point of using a public cloud. And each one of them have their own pricing matrices and stuff like that that they have to deal with. Completely out of scope for what I'm going to talk about. Now, can you mix the two together? You can, and what they refer to that as a hybrid cloud, where you have some stuff in your on-prem cloud and you have other stuff that's inside of the public cloud. Now, can you move stuff back and forth? You can. And some more and more customers that I talk to are moving to a cloud first or a cloud fronted deployment model for a variety of different reasons, and it wildly changes customer to customer. Some will use the cloud to run their ERP, Enterprise Resource Planning, their CRM, Customer Resource Management, stuff like that. So it really depends on the end goal of what the company is trying to do. Now, you and I, as the engineer and architect, have to come in and understand the needs of the business and then make suggestions on what we do and how we do it. So what capabilities are at our disposal and how do we attack that so that we can bring a technical solution to solve a business need. So those are the capabilities. I don't really have a cloud per se out here. This will be acting as a cloud at one point. So we'll talk about more in detail that later on how that's going to come into play. But that's essentially what you guys need to know is what I talked about so far. Fairly straightforward stuff. We're going to get into more of those individually, but as long as you understand the high level pieces and understand how the architectures are built, that's the key thing that I wanted you guys to take away from that. So if you haven't already done so, you can go ahead and comment down below if you have any questions, comments, concerns, feedback, all that good stuff that goes along with that. If you haven't already done so, please like, share, and subscribe, and I will catch all of you fine people in the next video. Have a good one, everybody.